Hi teacher, this is my second exam for the Mathematical Foundations course for the second unit. This is my problem of linear equations. So, this is the book Algebra and Trigonometry with Analytic Geometry from Sokowski and Cole. That's the 12th edition. So, 12. Only pay. A consulting engineer's time is billed at $60 per hour, and her assistance is billed at $20 per hour. A customer received a bill for $580 for a certain job. If the assistant worked 5 hours less than the engineer, how much time did each bill on the job? Well, as the problem says, 580 is the total. So, engineers receive what? I forgot this. The engineer is paid 60 per hour and his assistant is 20 per hour. So, those are the hours. We are going to let hours will be equal to x, and the assistant worked 5. The hours of the engineer minus 5. So this is going to be 60x plus 20x minus 5. So this is going to be equal to 580 equals 60x plus 20x minus 100. So minus 100, I don't want it right here, I want it here. So this is going to be equal to 680. 680 is equal to 60 times x plus 20x. We did this. Yep. So let me write this right here. 680 is equal to 80x. So I'm going to do this. X is going to be equal to 680 over 80. And x is going to be equal to 8.5. So, how much time did each bill on the job? Engineer's time was 8.5 hours, and the assistant time was minus 5 hours respect to the engineer. So this was 3.5 hours. So I'm going to make a pause right here only to write the compromission of this. So right here is the compromission. $580, that was the total of the paid amount, the amount paid. It needs to be equal to the time of the engineer, 8.5 hours times 60, the amount of money that the engineer receives per hour, and 3.5 times $20. So $580 is equal to $510 plus $70. So we conclude that $580 is equal to $580. So we can say that these results for the engineer's time for 8.5 hours and the assistant's time 3.5 hours, those results are okay. So this is our quadratic equation exercise. So it states, it is the number 67 of the exercises 2.3. Planning a freeway. The boundary of a city is a circle of diameter 5 miles. As shown in this figure, a straight highway runs through the center of the city from A to B. The highway department is planning to build a 6-mile-long freeway from A to a point B on the outskirts, so from here to here, and then from B to B. Find the distance from A to B. Hint: APB is a right triangle, so right here is our right triangle. Here's the right angle. So the distance from A to P plus the distance from P to B is going to be equal to 6 miles. So let the distance from A to P and the distance from P to B be X and Y respectively. Why? Because I don't want to let a lot of letters right here, and it is easier for me to solve this kind of equations. So, well, 5 mass squared is equal to x squared plus y squared. This comes from the Pythagorean theorem. So, well, 5 miles squared is going to be equal, well, no, this is not. X plus y needs to be equal to 6. Because it is the distance from A to P and from P to B. So well, we are going to make this y is going to be equal to 6 minus x. So well, 5 miles squared is going to be equal to x squared plus y squared. But right here we have this 6 minus x squared. So well, 5 miles squared is going to be equal to x squared plus 36 minus 12x plus x squared, and then we have 5 miles squared is going to be equal to x squared plus 36 minus 12x plus x squared, and only rearranging the factors, we have 5 miles squared is going to be equal to 2 times x squared minus 12x plus 36. I'm going to apply right here the quadratic formula. So let me write that and then the video will continue. So well, this is almost done. We were with this exercise. So we have this. Well, we have 5 miles squared. But then I was missing something. 25 miles squared is going to be equal to 2x squared minus 12x plus 36. So I need to make one thing right here. I need equal to 0. Well, this make it equal to 0. So if I have 25 here, I need to take 36 minus 25. So this is going to be plus 11. So well, with that, I'm going to apply the quadratic formula. So, well, x1 is going to be equal to 12 plus square root of 144, that is b squared, and 12 because minus 12, well, minus 4 times 2 times 11 over 2 times 2. So x1 is going to be equal to 12 plus the square root of 144 minus 88 over 4. So well, this is going to be equal to 12 plus the square root of 56 over 4. We can factor this, but in order to make this faster, we only apply this in our calculator, and we have that x1 is going to be equal to 4.8708, and x2 is going to be equal to the same thing, but instead of make assume here, we are going to rest the square root of 56. So x2 is going to be equal to 12 minus the square root of 56 over 4, and this is equal to 1.1291, and we are going to find the distance from A to P. So the distance is supposed to be this 4.8708. How do we how do we know that this is true? Well, we must remember that we have that the whole distance from A to B and to B was going to be equal to x plus y. Yep, and we say that y was going to be equal to 6 minus x. So right here we need to take this, and we can say that 6 is approximately equal to 4.8708. That is the answer for the distance from A to B. I'm going to write that right here. The distance from A to B plus the another distance from P to B, 1.12191, sorry. So that's the whole distance, and we are, well, that's the statement. That is equal, and we have the answer of the problem right here, 4.8708. So that was a quadratic equation. We applied this formula, and that's all. And the last part, I'm only going to write that right here. Okay. This is the distance, and the other distance is going to be 1.1291. So, well, that was my second unit exam for the course Mathematical Foundations for Mechatronics TSU on the utility. So, thank you, teacher.